Okay, let's start with the first question. This is from 2017, paper 1, question number 4. Okay, heavy rod is balanced on two supports as shown. How many forces are acting on the rod? Okay, first we look at, we have the free body diagram, draw the forces acting on this rod. The first force that comes to mind will be weight. Okay, if this is a uniform rod, the weight will be acting at the center of gravity, right at the center of this rod. Okay, and it's supported at two ends, so there must be normal contact force and one normal contact force and two. Okay, if this rod is supported symmetrically by both pivots, then we expect N1 and N2 to be equal if this is a uniform rod as well. Okay, so very easily we can see that there are altogether three forces acting on this rod. Okay, next we look at question 3 from 2018 paper 1. Okay, which of the statements about inertia is true? Okay, inertia is a concept that describes a body's resistance to change. For example, if a body is at rest, it tends to stay at rest, or if it's moving, it tends to continue moving. So actually, inertia, okay, is related to the mass of the object. Okay, it depends on mass. The larger the mass, the greater the inertia. Okay, and in fact, we have some books that talks about the law of inertia, about the behavior of object based on this property of inertia, and this is actually equivalent to our Newton's first law of motion. Okay, so we look at the statements now. Inertia is a force that keeps the body moving at constant velocity. That's not correct. Okay, the inertia is a property, but it's not a force. We don't describe it as a force. We don't draw inertia on objects either. Okay, so when you say it's a force, it's straight away is wrong. Okay, but inertia is a property of a body. It depends on mass. It does help to keep the body moving at constant velocity. It can prevent a stationary body from moving as well. Okay. Does inertia oppose motion? That would be a force like a friction that opposes the motion of object. Okay, so it's not a force, so we do not say that it opposes motion, because if it's actually moving, it will tend to continue moving. It tends to help a body to continue moving. Okay, how about the last one? Inertia is it's not affected even when body is in vacuum. Yes, when body is in vacuum, mass is constant. Okay, therefore inertia will not be affected. So answer is D. Okay, next we look at 2018 paper 1 question number 2. Okay, we have a description of forces on object, so it's best to draw the diagram. Okay, so we have a force acting on object. Force is pushing object, so just draw a very quick sketch of it. A force of push 25 newtons, and this object has a mass of 2 kg. This is your M. Okay, along a rough surface. So once you see a rough surface, we should be drawing the frictional force acting on it. Okay, it opposes the direction of motion of the object, frictional force. In fact, that is what the question is about. What is this frictional force? When the object is moving with an acceleration of 4 meter per second square. So we should also indicate the direction of acceleration, 4.1 meter per second square. Okay, and that's all information that we have. And now we can apply, based on this free body diagram, we apply the Newton's second law. Okay, F equal to ma. So net force will be in the forward direction 25 newtons minus the frictional force equal to the mass is 2 kg multiplied by the acceleration 4. Okay, so from there you can easily work out what is the frictional force, right? So in this case, you calculate and you should obtain the answer of 17 Newton, which is C. Okay, we look at next question. 2017 paper 1, question number 2. Okay, diagram is already given to you, so we just check that you have all the information needed. Of mass, block of mass 2 kg, right? So there are two forces, 8 Newton in one direction, 2 Newton opposite direction, and it starts to accelerate. So find the frictional force. Okay, so we expect that this object will be moving towards the right, because the pushing force 8 Newton is larger. So the acceleration will be towards the right with a value of 2 meter per second square, and hence the frictional force we expect it to be to the left. Okay, if drawing accurate free body diagram, make sure the friction is drawn along the surface of contact between the block and the ground, right from the center of the object itself. Okay, so again we apply Newton's second law of motion. Net force here, there are three forces. So in the forward direction is positive. Forward direction as in the direction of the acceleration is positive. 8 Newton minus 2 Newton, and also minus frictional force, equal to our mass of 2 kg multiplied by our acceleration of 2 meter per second square. Okay, so calculate carefully to find out what is the friction itself. And you should obtain the answer of B, 2 newtons for this